All, welcome back to my channel Hyderabad. In today's video, we are going to see about such an important algorithm when it comes to classification algorithms in machine learning. The algorithm that we are going to see today is support vector machines. This is one of the algorithm which has the ability to classify my data very clearly. In a way, it can set boundaries and classify the categories with clear differences. Even the differences are not clearly visible. So that is the power of this particular classification algorithm. So first, let's try to understand what is support vector machines. So what it is? It is one of the classification algorithm and it is a supervised machine learning algorithm, which means it has clear labels when I ask my ML model to classify it. The real life case studies include spam detection, image classification, face recognition, plot detection, and medical diagnosis. In these applications, what I need to do is I need to classify data which has minute differences, and my algorithm need to notice that and find it out. That is why I choose SVM for this kind of projects. The first step, what I have to do is import the required libraries when I do a SVM based project. The important libraries that I need here is NumPy is for handling numerical values, Pandas is for handling table dataset, Matplotlib is for creating visualization. Then I need a dataset, right? I'm using a dataset which is available online. That is, I'm using Iris dataset. Then I am splitting my dataset into training and testing dataset. For that, I need an library called train, test, and split. Then I need to use my model, right? So SVC, it's a support vector machine classifier it is. Then after doing all such things, I want to figure it out if this model is working well on my data set and giving accurate results. So that I need a report. My evaluation need to be there. So for evaluating, I need some metrics. That is accuracy score, classification report, and confusion matrix. These are the metrics that I'm going to use for evaluating my machine learning model. Now let's try to understand what exactly is support vector machine. It is one of the best machine learning algorithm, classification algorithm, which is used for finding the best boundary line. So it will be separating my different classes. So I can easily identify what is the difference. But what we call that as boundary? The boundary is called as hyperplane. The distance between the hyperplane and nearest data points is called as margin. So SVM's goal is to maximize this margin, because if I could increase the distance between the hyperplane and the nearest data points, that is the goal of support vector machine. By doing that, I can clearly see the differences. My ML model can understand it. Now, let's get started with the model building process. For that, I need my loading, I need my data set, right? So I'm going to load it. For doing that, I am creating a variable called iris and I am loading my data set. Load iris, which means I am loading my data set which is available online. It is actually a flawed classification model. We have generally three types: versicolor, virginica, and one more type. So I need to be classifying. Here in that particular data set, I will be having features and targets. So in these three types like Setosa, versicolor, and virginica, I'll be having features and targets. The length of sepal and width of sepal, length of petal and width of petal. So these are the features of my data set. And my target is going to be Setosa, versicolor, and virginica. So for that, I'm loading my features and loading my target labels into a variable called x and y. Then I'm moving forward with creating a data frame. So for that, I need to create and display my first 5 rows. So for that, I'm giving df is equal to pd.data frame of x. I'm calling this particular features. And then I'm calling my feature names. I'm storing that inside columns. Now I need to store my target inside y. That's why I'm giving df of target is equal to y. And when I want to print this as a table data, as a data frame, I am giving df.head, which means it will be printing my first 5 rows, which combines both features and my targets. So these are the features. First 5 columns of features and last one is target column. Now both got combined. created as a one data frame. Now I need to know what is the number of rows and columns in my particular data set. For that, what I'm doing is I'm just giving x dot shape and y dot shape. X in x data, what we have the features, right? These four columns. So in that we do have 150 rows and four columns. In my target, I just have one column, right? That is why I'm having 150 comma nothing. So it says it just have one column. Now I need to split my data set into training and testing data set. For that, I'm giving testing size as 0.2, which means 20% of data set could be used for testing. And when I give the printing statement like training data shape and testing data shape, and then I'm calling my xtrain shape and xtest shape, it will be printing the percentage. What I gave is 20%, right? So in out of 150, 120 is used for training and balance 30 is used for testing. So in that, it is printed this way. Specifically the X, which means the features. Now I'm building my model, support vector machine. Here it is SVC because it is support vector classifier. So for building the model, I'm giving model is equal to SVC. And I'm giving kernel is equal to linear, right? This thing I need to decide based on my data set. You should understand these things by doing a research and working with multiple data sets. That is main goal here. Followed by that, I'll be giving model.fit of xtrain and ytrain, which means I'm training my model here. Then I'm printing something to confirm these steps are done completed. So here I'm giving a printing statement like model trained successfully. So for a confirmation, I could use this printing statement. Now I need to figure it out how it is working on the testing data, right? The remaining 20% of data set. So that is why I'm giving y predictor is equal to model.predict of x test. So for the remaining 30 rows, it is printing my target values. And I can cross verify with the data to figure it out if it is predicting it well or not. Now I want to understand if my model is predicting well or not. That is why we have something called accuracy. It is an evaluation matrix. So when I give accuracy is equal to accuracy score of y test and y predict, it will be working on the testing data set. And it will be giving my accuracy, how well my model is predicting with a new data set. When I see one, it is 100% accuracy. Is this possible? Is this possible in real world? No. But in this particular data set, we just have 150 rows and clear labels and clear differences among each feature. So you can easily identify the target. My model can learn it easily. That is why we have accuracy is 1. But in real life data, it is impossible. So here 1 is correct because my model has very less amount of data and the differences is obvious. So my model could learn it properly. And also something called classification report is there when it comes to classification algorithms. It is used for evaluating my performance of the model. So these are the metrics like precision, recall, F1 score and support. This is used for identifying and understanding how well my model is working on the given data set. And another evaluation metrics is confusion metrics. This is specifically used for understanding how my predictions are correct and how my predictions are wrong. To understand the differences, there are chances it might be correct, there are chances it might be wrong. I need to know the differences and how many predictions went right, how many predictions went wrong to figure it out how well my model is working on the given data set. So I already mentioned something like this is very much important here. Choosing the kernel is important. So here we do have 4 different types. So here we have chosen is what we have chosen is linear, but we could choose whatever we want to choose. So I could use RBF. So whatever kernel I want to give and try it out. So for that also I got the accuracy as 1. But in other models and other data sets, the accuracy may not be as same as this. And finding out which kernel is suitable for this is a tedious task. You can understand the purpose of these kernels only by using it. So even I am trying to give a completely new data with different petal length, petal width, sepal length and sepal width, and trying to figure it out how it is predicting, if it is predicting my class well or not. So there is a condition that my setters of LOR will follow. So as per the condition, it predicted it well. It is actually a setters of LOR. So these are the concepts that you need to remember. When it comes to SVM, support vectors means it is actually the data point that is close to the boundary. All the data that is close to the boundary is called as support vectors. And if there is a decision boundary that is used for separating the class, that boundary is called as hyperplane. And the distance between that particular boundary and those nearest data points is called as margin. Remember these things. When it comes to kernel, you can use any kernel as you want, but you need to understand their differences. So commonly used kernels are linear, polynomial, and RBF. So why I need SVM when we have so many ML algorithms, classification algorithms? If I have a data set which is small and medium sized, I should use SVM. I should give preference to SVM. And when I need my model to be powerful when it comes to classification, I could go with SVM. If I have a data which has high dimensional spaces, then I need to go with SVM. And I want my model to predict well and give a high accuracy rate, then I should choose support vector machines when it comes to classification. See, we have drawbacks too, and they are it is not suitable for large data sets, and it is harder to interpret, which means we can't combine this with other logics and other algorithms. In this particular algorithm, the worst difficulty that we are going to face is choosing the right kernel, because it is not as easy as we think. In real world, we have already seen the applications in detecting the spam email, and for face recognition, cancer detection, any disease detections, classifications, text classifications, and if I want to find out which number it is based on handwriting, the handwriting recognitions, for that I could use SVM. So as a beginner, you can take screenshot of these tasks and give it a try. Yeah, I believe you took screenshot. So in this video, we clearly saw what is support vector mission and how to work it from scratch. If you are a beginner, I believe this video really helped you a lot in understanding what is SVM and how to code from scratch and work with the data set. Bye for now. We'll meet you in next amazing video.